Compare and order fractions. When they say compare, it'd be something like this. If we had comparing like this, 3.4, 3.6, or 3 and 4 tenths, 3 and 6 tenths. So it's 3.4, 3 and 4 tenths would be what? Less than 3 and 6 tenths. Okay? So we would say that would be less than. So today, we're going to have fractions. We're going to have decimals. We're going to have both. We'll have to compare. We'll have to order. Now, can I put this one into a fraction form? How about this one in a fraction form? Does that change my inequality? Does that change? Is it still less than? Still less than. Okay. So sometimes they'll give you one that looks like this. And you'll have to figure out, is it less than or greater than or possibly equal? Is it accurate to assume one or the other without doing what first? It's easier to really tell if what? If they're written in the same form, right? So either I decide to put this decimal into a fraction, so it matches this one, or I decide to put this fraction as a decimal and compare it to the other. Now what's easier? I'd say it's probably situational. Good thing you know how to do both, because sometimes you'll need it. With fractions, let's take a look at fractions first. We'll just take a look at a pair of fractions. Let's say 3/4 and 9/10. Now, they're both in fraction form, but what makes it just a little bit more difficult to determine which one is larger and which one is smaller? What's different about them that needs to be the same for me to compare them accurately? Right. The denominator. Very good. So I need to start thinking about multiples that will work for both 4 and 10. Now, I'm not going to require that you set up a factor tree for 4 and 10 and find the LCM. But if we focus on the 10 and not the 4 and start listing our multiples of 10 and seeing which ones work for 4. Does 10 work for 4? No. What's my next multiple of 10? Does 20 work for 4? So here we go, 20 and 20. So I'll put both those fractions into 20ths. So each one's going to be different. The bottom number. To get from a 4 to a 20, I had to multiply the 4 by what? 5. So I multiply the top by 5, and I get 10. Is it by 5 to get 20? By 2. So 9 times 2? Therefore, we can say that 3/4 is less than 9/10. Once we can convert them to the same denominator, we're going to be just fine. Okay? Let's look at another one. Let's say 2/3 and let's say 1/6. Might be easy, but we should still go through the process. When I look at the two denominators, the 3 and the 6, let's use the 6. Now, does 6 work for 3? Then I can go ahead and use that 6. 3 times what is 6? 2. So 2 times 2? 4. 6 times what is 6? It's the same 1. Therefore, 2/3 would be greater than 1/6. Yes. Yeah, but as a math teacher, it's difficult for me to say, yes, you can do that. We need a process. And you can't always tell by looking at fractions which one is larger. So like if I were to take, how about 7/9 and let's compare it to 6/8. You say, well, maybe the difference between the numerator and denominator is 2. It's 2 here as well. Do we know for sure? Until we do what? Gotta find it. So 9 and 8. Least common multiple between 9 and 8. Anything that comes to the top of your head? Do you need to use the smallest one? Not necessarily. 56 wouldn't work for 9, because 54. 8 times 9, we can use 72. You can always find it by multiplying the two together, but that's not always the fastest way. This might not always be the smallest way. 9 times 8 is 72. 8 times 7 is 56. 8 times 9, 9 times 6. So pretty close. 56, 54. That one's bigger, but just by a little bit. That's why it helps to have a process in which we can check it, and we can really try to find out for sure how they relate to each other. And that's the process. Okay? What happens if you see a mixed number? Like, let's say 2 and 4/9 and 2 1/2. In this case, what is the first thing that you are going to compare before you do anything else, Mariah? The whole number. So now the whole number is 2 and it's 2. So they're the same. So now I'm forced to compare the fractions. So between a 9 and a 2, what are we going to use? Decide. 18. Okay? 9 times 2 is 18. 2 times 4 times 9. Ooh, it's 2 1/2, which is greater than. Very good. 4/9 is going to be just a little bit less than half, right? A little bit less. Okay? Any questions? Do you want to try a couple? Casimir? So what part of this confuses you? Oh, which one is smaller, which one's greater? The open end always goes to the one that's bigger. Okay? It's like, what do they always used to say? Like the alligator? Okay. The open end is the bigger end. Or you could say it points to the smaller one. See, because people get confused. Because that kind of looks like a bird's beak, right? Birds like to eat too, right? So why don't they want to eat something? Anyway, so maybe you look at it that way. The bird's going to eat the smaller meal than the alligator. Right? The bird. Bird. I don't know. Never said I was good at art. All right. 5/10 and 3/4. What do we want to do? Do you want to convert the decimal to a fraction? Do you want to convert the fraction to a decimal? What do you want to do? Larissa? Decimal into a fraction. What is this as a fraction? 5/10. So I'm comparing 5/10 to 3/4. Okay. LCD, lowest common denominator between a 10 and a 4. 20. Times 2 is 10. Times 5 is 15. Which one is greater? 3/4 is greater. Yes, ma'am. This one here or this one? Okay, so here, watch. Real carefully, okay? I said this is the 5/10 as a fraction. I said I'm going to put 20 as my bottom, right? So now I'm going to look at both the bottom numbers. So I started with a 10. How did I get to a 20? I went times 2. So if I multiply by 2 to get the bottom, I must also multiply by 2 to get the top. What's 5 times 2? 10. Whatever is done to the bottom has to be done to the top. Okay? Try one of these. Decimal to a fraction. Now you do realize that if you take the decimal and you put it into a fraction, that you're going to have to do what else? If I decide to use this, which is okay, what other step am I going to have to take?
You're going to have to bring that other one down and then times.
I have to get them into common denominators. Okay? Just okay. So between the 10 and the 5, we should probably use a 10. 5 times what? 2. So 2 times 4.
8.
So 1 and 8/10, 1 and 8/10 must mean that they're equal. Carlos? Well, let's use the same one. 1.8 and 1 4/5. If I want to go this route, I want to put them both in decimal form. How is it that we put a fraction into a decimal? Do you remember? Using division. Which one always goes on the outside? Denominator. Because as we look at 4/5, does it give me a value just the 4/5? Does it give me a value less than 1 or greater than 1 whole? Less than. So if I already start off with a fraction here, it's going to give me something less than, I'll be in good shape. 5 going to 4? No. How many times into 40? 8. So I already have the 1, and I add the 0.8 to it. Should still get 1.8. It's all about what you're comfortable with. Maybe you just prefer to put them both in fraction form and then convert denominators. That's fine. That's okay. All right? Now, we have 4 different terms to work with. And we're going to order these from least to greatest. Okay? So 2 of them are in decimal form. 2 of them, no, 3 of them are in fraction form. 1 is in decimal form. So we probably would be best off converting the decimal to a fraction, right? So 75 hundredths is what that is. As a fraction is what? 75 over 100. Right? Okay. Are there 2 of them up there right now that you could tell me are smaller than any of the other 2? Can we separate a couple of those right away? Carlos? So this one and this one are both going to be our 2 smaller ones. So which one is going to be smaller? Do you want to keep 75 over 100 and find out the common denominator between 3 and 100? What would it be? 300, right? Convert them both to 300ths, or what? Anything we could do with the 75 over 100? Can I simplify it? 25. Desi? 75 over 100 is better known as 3/4. Now, if we're comparing just the 2/3 and the 3/4, What are we going to use for our common denominator? Let's use a 12. Isn't 12 much nicer than 300? So now, my bottom, 3 to 12 is times, so 4 times 2, 4 times 12, 4 times what gives me 12? 3 times 3? 9. So we could say that which one is larger? 0.75. So now, over here, in its original form, I'm going to put those first two in order. These are locked. Those are locked in. Now it's a matter of choosing between the 1 1/3 and the 1 1/2. So did we really order 4 of them? We really only ordered 2 sets of 2. Because we were able to tell just by looking at these which ones were smaller, which one were going to be bigger. So are both the whole numbers the same? Yes. Between 3 and a 2, what's the common denominator? 6. Let's convert them both to sixths. 3 times 2 is 6. 1 times 2 is 2. 2 times 3 is 6. 1 times 3 is 3. So therefore, this one is smaller. So the next one in line, followed by 1 1/2. There is my final order. What else do you notice about the final order? All of those terms are in their original form. What's their original form? The original form is what they came to us as. Okay? They're all written the way that I started with them. Okay? Ready for one? Of course. There you go. Okay. Now, when I said it's all about approach, it's how you look at what you're working with here. Is there any of those up there you know right away you could put somewhere? Yeah. That's going to be my greatest one. That one's done. Why is it my greatest one? It's the only one that has a whole number 1. All the other ones are going to be less than 1 whole. Now, I think that some of you probably took that 0.6 and put the 0.55 and decided to put them as fractions. Now, if I got 2 decimals and 1 fraction, I'm probably going to, if it's me, I'm going to convert 5/10 to a decimal. What is 5/10 as a decimal? If I said close your eyes and think of the decimal, 5/10, what would that be? To Caleb. Good. So now it's a matter of ordering 0.6, 0.5, and 0.55. When I want to compare decimals, it's wise to do what? Line them up. So let's line them up. Let's take the 0.6, line up the 0.5, and the 0.55. Can I fill these in with zeros? Sure I can. So now, as you look at some of your answers, some of you may want to switch your tune a little bit. Those first ones are all the same. Which one is larger? Okay, so I'm going to have my 1 1/3. The next biggest is going to be my 0.6. Now it's a battle between those, and what's bigger, a 0 or a 5? So therefore, the 0.55 goes next, and the 5/10 is your smallest. This isn't a 5. It's a 50 if you line everything up. Okay? That's not a 6. It's a 60 if you line everything up. Yes? Right, but what happened when we compared them? Which is greater in the 10th place? The 6 or the 5? That means it's automatically bigger. Okay? It's like this, Alexis. If I said you had 60 cents or you had 55 cents, put dollar signs in front of it. Which one's more? That's why you line them up. If you line them up, it becomes pretty clear. If you try to do it in your head, that's probably the major trick with the decimals, is you should line them up. Otherwise, you fall into those traps. Okay, let's take a look at our sheets. You should have this on the back of 4-2. Yeah? Now you got one.